Hi and welcome to our webinar about predictive tracking. We want to start punctual as we want to finish punctual. So let me give you a short introduction. My name is Konrad, and I will just provide a very quick overview about our prediction approach. The most part of this webinar will be done by Jens, as he is the responsible developer, and he's the most, let's say, competent person to introduce our predictive tracking solution. What do we mean with prediction or predictive tracking? Despite from GPS tracking, from where we receive location data, let's say very frequent. At predictive tracking, we receive sporadic reads from the timing devices, let's say from the decoder or track boxes, which are spread around along the racetrack. And our algorithm is able to compute this sporadic information about the race into a, let's say, realistic and smooth visualization. So I think this is enough for introduction, and now Jens will give you more details.
So yeah, welcome to the webinar. I want to introduce myself too. So I'm Jens from RACEMAP. Some of you maybe already met me at the conference in this spring in Mallorca, and we had some discussions there too. And I want to present you our prediction solution here. So therefore, I will share my screen. From the beginning, we tried to make it high performant on our servers, so that you can use this prediction feature with big events like marathons with up to 20,000 starters or something. Oh, this is at least the highest we have tested for now. So we are open for events that have even more starters or participants. So as I mentioned, it's not real life tracking. So, but this is also an advantage, hands off, because if you want to host a really big race or use this live tracking with GPS hardware for maybe 10,000 starters, it's really hard to do all the deployment, give them to each starter, recollect them after the event, and so on. So the timing hardware is most of the times anyway on the race ground, because the people want to have the times, the start times, the finish times, whatever. So it's a good way to use this. There are certain scenarios where you need really GPS tracking or phone or tracking with apps. Then you can, if you really rely on the precision, or if you don't know where the track is. So there are other scenarios for this. But if the track is very clear and you have a relatively good knowing of what will go on your race ground, you can use this prediction. And it's an easy setup. So this is this webinar about. So I will show you how to set up a prediction. And another advantage is it will work. It works for all participants. So in the case if you have a GPS tracker set up or a phone tracking set up, you require the participants to really take part, to really open the app, press play, activate the tracker, take them with them. So don't let it in the sports bag or in the backpack on the start. So that's the thing. If you use prediction, most of the starters already have their bib attached to their running shirt or something, because there's also the race number printed on it, or the start number, and so that they forget this is not so common. So also an advantage. So now let's dive right in. I want to show you what you can do before an event to set up a prediction race map. So we go here. So obviously, it works with RACEMAP. We have the website. We have a website where you configure your event, and it looks like this. We have a small landing page where you also can see a player like this. And this is the goal, what you want to have. You want to have a player that shows your event or your participants in a fancy way. So can also show you, it could like this, look like this. This is a half marathon from Munich last year. It has really a lot of participants. So that's the thing. You can configure this player a lot in different ways in the background, and then you can have dots or all small signs or different colors or whatever you want to choose. But this is this webinar is not about how to configure this player, but how to set up a prediction race. So just want to showcase you that you can have small events, big events, and it can look like this. So you go to RACEMAP, you log in, and what you first need to do is to set up a race. So we can go on the top here. There you create a tracking map, and then it's just about the name, like always. And I choose Dresden because this is where we located in Germany. And I will select just a bike race, MTB one. And then you have some times here. So today is the 31st of March. So I have to go back a little bit and should just be a 1-day race. And now it's a little bit too early, so we will need some additional time for preparation. So I guess we will start the race at 9:20 and let it finish at 10 o'clock or something. So not 14 o'clock. So we have it from 9:20 to 10 o'clock. So why this start and end time? So your timing hardware will be set up to forward the location or the data to our system. But this time, the start time of the event and the end time of the event is basically the time frame where we use the data. Everything before and everything afterwards will just not be used. So it's kind of important to set these times as the outer border. So, okay, we can go back and have a look what else should be done. So we choose a name, we choose a location, we define the type of sport. Why the type of sport is kind of important. So the prediction, as I mentioned before, sometimes uses your hardware multiple times. And if you have a loop with one reader that always pushes data to us, we have some speed filters to ensure that we do the right mapping. So, and the speed filters are defined kind of depending on the type of sport. So if you choose running, the max speed that is allowed is a little bit lower than if you choose biking or a motorboat race or a motorcycle race or something. So, but it's very straightforward, and most of the time you know what kind of race you have. So what else very important is the shadow track. I mentioned as a big advantage of our algorithm is that we do this auto mapping here. So we get a location and just map it to the track. But to map it to a track, we need a track. So this track we call the shadow track. The shadow track is the unfolded race in its full completeness. So if you have multiple loops or you have a water race or something, then the shadow track is really the whole race from the start to the finish line with all segments in between. And to upload the shadow track, you just go to map. And then you have the menu here on the right side. You can add a track while just editing the map, but this is very slow and it needs a lot of time. Most of the time, you already have a track that is recorded somewhere by a GPS device, or you have it from the previous event from last year, kind of a piece of data. So you can choose the upload option. I already prepared it here. I will choose this track. We select it, it will be imported. You get this green sign here on the right side, and then somewhere there appears the track, and then you could zoom in to get it. and see if everything was right. So that's this thing. So let's go what we have to do else. So okay, now comes the most part with RACEMAP is done now. So you have a track, you have a name, you have a sport location. And now what you else need, you want to have the information for which you want to, or which starters or attendees you want to show. So we built some ways to get the starter data into our system. And I want to present two ways here. I want to present the race result way and the generic import. So in both ways, the starter data is already in another system. So you have it somewhere. Because there are other software systems, they do the registration very well. And to get more help how to do it, you also always can use our support section. And then you get to the page docs.racemap.com, and there a lot of the stuff I'm explaining here is also explained. So what the next step we want to do, we want to import some starter data. And this is this big section here, import participant data. And then you can use APIs to do it. And I want to present first this generic import. It just uses a location from the internet where you save a file and we can import it. So this file has to have a certain format with some informations inside, like the start number, the name of the starter, and what's important, it has to have this device ID. This is what the matching then will present to the signals we get from our timing system. So it has many different names. Some people call it BIP. It's a transponder ID or device ID or whatever. But this is a matching number that matches the starter to the signal or the data we get. So to do this in live, I prepared a small tool here where I can simulate a race. So just imagine you're outside somewhere on this planet and you want to start a race. You already have registered starters. I just on my race here, it's 8 of them. They have different names. It's just randomly generated names like this Clemens here or Brandon. And they also already have a transponder ID or BIP or whatever. And I just generated them for different timing systems. In our database, we prefix them to just to know a little bit from which system they came from. So, and they will have a random speed, and they will then race over this map here. And we will simulate this race like it will be in real. So the starter will run or bike, and then if he passes a timing system, it will generate some data and push it to our servers. So what I show you now is that if you have the starter list somewhere in the internet, maybe on your servers or some other servers, then you can go to the import section of your event in RACEMAP, and you can click on this right icon here. You can activate the import, and then you place the URL there. And if the data inside this location here is well formatted and has the right information, we will instantly show you this green check mark to indicate that everything is okay. If there are some errors, you get a small list here what you should change maybe. So this import is now running in the background. It's not syncing every second, so it will take a while to get running. So be patient there. I think it's every 30 seconds or something like this. So let's go back to our schedule. So, okay. The last thing here is, and this really we encourage you to do this before the race. We know before races you have always less time and there's so much other things to think of. But testing is really gives you the power to don't get any surprise on race day. So you should test and forward your data the race ground. So, and I can also do this with my small little tool here. Let's assume we have it's just before the race. So and somebody is putting the hardware onto the race ground. This I can do here with the button, but in real time you have some of your staff people going around and placing this timing hardware around the track. So it's here indicated by these green bubbles. So here we have a timing system that will read. Here we have a timing system, and I placed one next to the start line, and I placed another one a little bit up front to the start because I want to have an early signal. The prediction works that we do the measurement from here to here, and then we can calculate a velocity or a speed, and then we extrapolate this for the next of the race. And if the next timing system is coming, we use this data and then correct everything else. Or we slow it down or speed it up a little bit. Okay. So, and it's in general better to have a little bit more hardware. So if you have a lot of hardware, just place more hardware on the track because it will improve the prediction quality. This I will show you later. So to test the thing, you just activate your hardware and then you generate some signals and they are forwarded to our servers. So then you can check this again. If you go back to the race, to the setup page. So in RACEMAP, you already see now that we have a small 8 here. So if I go back to the participants list now, I see that everyone has data inside. So the import has worked here. So our servers just draw the information from the other server, and then you can see it. You see everything here. You can define a lot of stuff like the age or the gender and the name and the race number and so on. For me here, it's just random numbers, but it has worked. So now to the real prediction. To set up prediction, you also have to activate it. So there's this button here on the top of the right. You agree to the pricing and the terms of use, and then you activate the event, and then the prediction will take place. Just press it, and then you see on the small status page here that you get a lot of green check marks. And if everything is green, you're ready for go. So as I said, we wanted to check if some of our data is getting into the system. And therefore we go back. And one of my virtual readers was this one, this 5948. And I triggered him to send them some timing data to our backend. And you can see it here, this reader 945948. The data was here, and I got a lot of readings from this reader. It's so, and this is the table you can use before the race, while the race, and also after the race if you wanted to research whether your data was coming to our system or not. You get some information here. So I assume that your timing system is able to also forward locations to us. Some timing systems does not do this, but this I will show you later. The best case is that you generate this GPS location locally and always send it with your data to our systems. And you can see this here, that the location is known. You also see which was sending the information. If you use this generic import, you see kind of your user ID. And you also see, if you use a race result import system, that it's kind of used by a race result user, because therefore we encode this user ID here, and the customer ID, it's called like that. So this is working here. The hardware is set up right. The data is forwarded. It's getting to our systems. We also have this small tab here. There you can see locations of hardware. So as I mentioned that there's the shadow track. This is a track where the race will take place. And then you have this map here where every data we get into the system that is kind of belonging to your race here is shown on the small map. And the auto mapping I mentioned in the beginning is working, that we have a small corridor around the track, and everything that fits into this corridor will take it into account for the prediction. Sometimes if you have timing system that is mobile and you place it too much away from the track, you will see it here, and then you will get a warning that it's too far away. And then you will have a warning that it's not set up right. So now let's start the race. So in my case, I will just start the race by by triggering the start gun or something, and then the starters will just run. Imagine now we are somewhere outside and the people taking their bikes and just start biking. So the race has been started and they are already crossing this first timing system here, and the timing system is generating some data. So that's the thing now. We did everything we could to ensure that the race is set up well in the beginning of or before the race. So I will reframe this. You went to RACEMAP, you had an account, you created your event, you choose a rough location and the name for your event, you selected well the type of sport, you uploaded the shadow track, and you imported some starter data. Then you also tested this forwarding of your timing data to our system. So now we transition to the next part. The race is running, and what should be done there? So I mentioned that it's crucial to at least have 2 measurement points to define the speed of a race. So, but if you have a start time, we can use the first location, the 0 location also. So if you want to have quick results, it's good to upload the start time to our servers. This can be done indem you just rewrite the file that we already imported from some of the locations from the web. And I can do this and then just re-upload the starters file, and our system will then sync automatically every 30 seconds from this location. So if you update the start times in the starter list, then we can read it again. And can also use this location here as a data. So then we get the prediction running not at just at this location here. We can also get it running here if it's set up fast and right. So that's one thing you should do while the event. And then you can go back to the analysis section I showed you to recheck if the data is coming to our system. You can also check the location of the readers again, and the read stop. And then you can also check the player for upcoming data. So this I will show you now. So we can go here again. And sometimes it's good to just switch forward and back. So updating. And now we see we already have data from this timing system. This is the name I choose to just give a little bit insight where it is. There's a timing system in 200 meters and one in 600 meters, and we already get data from there. And it's already mapped to these participants. So the re-import of the start time has not worked for now. So we have to wait a little bit more. But here you also can check the list of the starters that have a transponder and are used in our prediction system. So let's have a look at the player. Some of them are already marking this, passing the third point here. The 1.5 kilometer mark. So let's go through the tracking map. This is what the customers or the customers of your customers will see. This is what's all about, the live tracking in our player. So as you can see, the race is working, the prediction is working, the player shows some data. And we have this feature of instant replay. So while the event is running, you also can move back in time, go back in time. And there you see the race starts already at this location here, because we know the start time. We already know at this position here is speed or velocity for each starter and can start the prediction. So this is good. Then you can switch back to live and you see that the race is unfolding here further. So we did everything right. Data is flowing. The player is showing something. So we can go back to the while event checklist and we updated the start times. We got back to the system to check if we have some incoming reads. We already checked again that my hardware is close enough to the shadow track. And this is the thing. In some races where you use hardware that is transmitting data, like there's this one system we know from RACEMAP where it's called Trackbox, where you can have where you can mount the system just on a street lamp or somewhere a little bit far away from the track. It's sometimes a little bit too far, or you don't find a good location to position it. Then you also can change the configuration of our prediction algorithm a little bit. Therefore, we made this setup section here, and we have this for the most important parameters. We have this 3 small animations or pictures to somehow visualize what the setting is doing. So if you know that it's not possible for you to position your hardware next to the track, or you maybe need a little bit more space, you can increase this number here. And then you have a wider corridor or a wider area around the shadow track where the data is taken into account. Or this is what I will explain you later. Sometimes the prediction is not good. So it's mostly not for running events, but if you have biking events and you have a lot of elevation, the prediction by measuring the speed in the past and predicting it into the future is not good enough. So because they go down the mountains very fast. We will work on this in the future, but currently it's like that. And then we have an error. So the biker is already passing the next reader, and we know, okay, we predicted them wrong. And therefore, is this small parameter here? It's like a time that we allow the predicted data to be wrong. You can change this time and make it smaller. And what happens then? You see it here in this animation. The blue one is the predicted starter, and it's too fast here, so it passes the reading. And when we know that the real starter was here, and we know, okay, it's more than maybe 60 seconds, we do a jump. So we don't smoothly correct the starter. We really take them off the map and set them to a new location. So this is why we call this is jump, and the jump threshold in seconds you can define. So it's mostly used in very long races where there's just a few timing hardware. Then the longer the race track is with a fewer readers deployed, then the bigger is the possibility to have this prediction errors. And then the jumps are really good to reset the starters to their right, to their most right position for this moment. Yeah. And then we have also this settings for systems that use this transmitter technology. You can define a thickness range where you don't use the information anymore. So this checkboxes from RACEMAP has the thickness strength information, and they really transmit sometimes or recognize signals very far away from the track, and then it will lead to some errors in the mapping algorithm. So you see it here. It's kind of also defining a range where you accept the signal. we found that this parameter of -75 dBm is very good. So most of the time you don't need to change it. So let's go back to the race is still running. So we can have a look at the player. You see some of them are passing the 5K mark. We can check this with simulator here. Two of the guys are very fast. They're on top of this small curve here. And if I go back to the player, they have in the same location. So we already see that the prediction is kind of very good in this case. So, and what I also want to show you is the second way you can import starters. Okay, and I want to show you how you do this with the race result system, for example. So, for those of you already have seen this system, they also have a backend where you can log in, and we have a race there too, just a small race where we set up some starters just to showcase you that we can import from other timing systems too, and for other registration platforms. In RACEMAP, it's called Simple API, and they have this configuration dialog where you can define which information should be present in the file you can download from their servers. And they also, it's this small Internet Explorer icon here, generate the link where you can draw the starter data from. And it's just machine readable data. It's JSON, and it works like the same, like with the generic import I showed you first. You can just use this location, go back to your event, go to participants, go to sync, and also activate a second import source. So here you just have to activate it again with the small sync button. It's also very, very, it has a green check mark, and then you see that it will work. So that's the thing with our system. Everything works in parallel. So you can have multiple sources to import starter data from multiple systems, and we are open to generate more systems here if there's need on the market. So, and then after a while, the server will start this sync loop, and then the counter for participants will raise up. We can have a look again at the system here. And now we see that also the import of the start times has worked. So the event start time was 9:20, and now we have this 9:23. So, and it's in individual time for each starter. So this thinking of the start time also works very well. So, and the second thing, so now I showed you how to import starter data or participant data from a different location, and what is with this reads, we call it, from maybe the race result system. It's also already automated in their system because we worked a lot together in the past. So they also integrated RACEMAP like other tracking providers into their system, and it's called forwarding. So if you use race result hardware, you can go to the system section here, and they have this setting for an active track box or a passive track box, where you can select this tracking partner. So, and there are a lot of options. So, and RACEMAP is one of them. And if you want to use RACEMAP and forward the timing data to our server, you just should use RACEMAP here and select this from the drop-down box and apply it. And then it will be said that every hardware that is also sending reads to RACEResult will also forward the data to our systems. So it's very straightforward. And you can cross-check this by going to the prediction setup. Now we see that the import of another bunch of starters has already also worked from another system. And so now we have a bigger starter list with just 13 attendees. So let's go back to prediction. There is this one thing here in this status page where you can choose the RACEResult system, and then you get additional options here, what you can do, and what we built in our servers, that we just check this setting, that this setting here is right from external and show you. So before you just need your RACEResult customer ID, and you can obtain it from here, or you already know it from your memory. Then you can edit this here. And what this small system here does, it checks this setting here, and it also pretends to be RACEResult hardware. So it's like a track box or something. So we send a read to the RACEResult server, and then we get back data from them. And if this is working, then you get more check marks. This is not done very often, I think once in a minute, and then the data is getting back, and then you can double check the tracking partner has set right, or if this is working now. I think the next sync will be in 1 minute or so. So, okay, let's go back to our slide to see what's going on. The race is progressing very well. Some of the starters will arrive in the at the finish line, and it's also here in the player. So yeah, you see also that this color setting has a meaning here too. So you can import settings for the player from the participant import too. So while the event, we check the player. It was working. The data is coming in. We also have the start times there, and it's the same for the finish time. So to really want to have a correct player where the people are at the finish line at the right time, you should also forward the finish times. So let's go to the after event section. What you can do after the event. I mentioned this again. Check your times. Sometimes this is wrong, or sometimes it's out of the event time or within the event time. You can see it here. We have this transponder tab here, and if all the start times are known, you have a list here to the RACEResult system, and if this is green, then you know that it's within this event time frame. I told you in the beginning, so the event time is just the course time frame where everything within is taken into account for prediction. And if this is done right, it's green. And you should have both of these columns filled up with times and be green. So after the event, you can go to the analysis section. And this is one of our tools that we use for ourselves to really improve prediction, because here you see all the data for one participant. You can select it in the dropdown, and then you see, okay, for this participant, I have this information, this read. They are all within the vicinity of the track, so they were taken into account. You see them on the elevation profile, and you can double cross-check. So if you go with the mouse over one of these locations here or one of these locations, you see the reference location marked with a small red circle on the map. And you also can see this is in a list form. So you can see which was the reader that was producing this read, because you see the ID here. And if you give it a name, you see the name here. You see what we mapped it to. So in terms of offset, we call this offset. It's the distance on the track from the beginning. So the first signal was on 0 meters, obviously. And then you got this list here. Sometimes we don't expect, or we don't take your signals for prediction. And this because this is we call this accepted reads. No? This is a list of accepted reads. And some of the reads are sometimes not accepted because they are too far away. They are too fast, too slow, whatever. And then you can get a reason why this was happening here on the last column. And then you have to switch the small little switch here to see the trash. Yeah. So in this tool we use very often to see the quality of the prediction. So I can show you another example for a race that is already has been over, like this motorboat race from Australia. And there you also see they choose a wider location because it's somewhere in the countryside where there are small channels where they race with their motorboats very fast. And maybe there it's a little bit harder to put the timing hardware in the right location. So they give them a little bit a bigger corridor to accept reads. And what they also did is they had these loops and they had this crossing here. So they have one of this hardware that was very at the crossing and on the loop. This track box 230099. So, and what I want to show you is that then what happens that we really use this information multiple times. So in this case, this hardware was used 4 times for this starter. So you had one timing hardware, but you produce 4 locations for the race. And this is really good for prediction quality. So you see, they have a lot of timing systems here, but it appears so much because a lot of them were used multiple times. And then you can reduce the error. And we show this error on top of this analysis section. This is what we also want to be. We want to be kind of transparent in terms of the quality of our algorithms. So you can check here. And what this means, I try to explain. So you are on the race ground and you have a mobile phone or whatever, a tablet where you open our player and you see the starter on the map that we predict. So, and the player shows the starter is at your location. And then you look left or you look right, and the real starter, the real one, is just within the range of 376 meters here. This looks very high at this moment, but you have to consider this was a motorboat race and they were racing up to 100 kilometers per hour. So they cover this distance very fast. So it's not, it's a very good prediction quality for this type of race. Where you also can see this is in this chart here. And there you see the comparison between the yellow line and the green line. The yellow line is what we predict while the race is running, and the green line is what we know afterwards. So afterwards, we know everything. Now afterwards, we know this guy was at this location at this time, and we really can say, okay, this was the truth. But while the race is running, we don't know when the next time indication comes, or is the guy stopping or running faster or slower. So there is a deviation, but we try to minimize it. This is the goal of prediction. And you see here, there was a jump, or a stop, and then it was heading in again. So you can do research, and therefore you can change maybe the setup for the next time. So this is all live here, though you can maybe add more jumps at an earlier time, and then this error matrix can change. So you get a feeling if you change some parameters, what would be the result. for the prediction in the players. And this number here is the number for the whole race. So this was the error rate for this starter here, for Mr. Morena. And for the full race, it was 400 meters. To calculate this number for the whole race takes a long time. It's the reason why this number is not always appearing at the beginning. So let's double check again. So check finish times, do analysis. I showed you how to do it to maybe learn something for the next race. And this is also something I want to show you. You should check is this transmission times. If you go back to an analysis section, I like this reads tab here. You see there's a small number in brackets after the received time. And this shows how long did the signal take to come to our servers. In my simulation case here, it's very, very good, 0 seconds. So the signals were instantly at me. But let's say for this race in the remote location of Australia, it was a little bit different. You see, there were some signals, they got to our system only after 12 seconds or 16 seconds. This is still very good for a remote location like this. I think they used some mobile internet provider or some satellite internet to transmit the data. And sometimes it happens like this, it takes a longer time. So here, it took already 30 seconds to know, for RACEMAP to know where this guy was at this location. So, and the longer this time takes, the less good is the prediction. So always check this too. Maybe you sometimes have issues with this, with your internet connection. And then it could be a reason why prediction is not working. We have already seen here some values in the range of 5, 6, 7, 8 minutes. So yeah, did you got signals from your hardware? Sometimes your hardware is just not working and then we don't get anything. So you can check. How was the distribution of your readers? Was it very well distributed? Sometimes it's good to have, if you have a elevation profile, to put more readers on the downside of the mountain, 2 of them to get a better prediction and so on. How was the distribution? Just check in our maps. I also showed you the error. You could have some influence of this. And maybe make some notes for the next time. Yeah. And I showed you the analysis of this Riverland DigiDMB. This motorboat race was provided by Aaron Clark from Event Time in Australia. And I can also show you this Munich Half Marathon data spot analysis one more time. Because here the error is already also very low, but this is most of the time the case if you have the street running races, because the speed does not change so much. And this is really a good use case for prediction. So the errors are low. You don't need so much hardware. You already have it there because most of the races want to have split times, and it's very good to use the prediction algorithm there. Okay, that's it. Some questions and answers. While you registered to this webinar, we got some questions of you, and I want to just go through it. So one of the question was, is it a real tracking based on actual data and location, or is it just computation? So the answer is both. So we get real data, but it's just less and a few points, and we do some computation on it to let it look like live data. And it has some drawbacks. I showed you, if you have not enough hardware or the transmission times are too low, then you get a not so good quality. But how is it, or then the question was, how easy is it to use it or to set it up? We did in this webinar a full setup. We set up a race, we imported starters, we distributed timing hardware. Okay, it was virtual, but in reality, it would be the same. Just go outside, put it, switch it on, and the data will flow in. So And it's not so much things to configure to have it running. So I think there are just much more other things to do on race grounds on race day. So, and this is the thing, we want to keep these as lean and small as possible to don't put any more effort onto US timers if you use prediction. It should be just clean and easy to use. And if you have some ideas how to improve this further, just let us know. We also got the question how it works for race result systems. Yeah, it's true. A lot of you guys that use race result at the current have this race result hardware. So I showed you also this case. And there was this really special question. I have a race result passive system with just 5 decoders. What can I do? You can use this system if you forward start and finish time. You kind of have 7 readers or 7 decoders. So it will already produce a prediction, but if it's a long race, it will not be good enough. So I would recommend maybe just a half marathon or something. And then another question, what were the key improvements than the last season? So all the analysis tools I showed you, we built into our backend are kind of new. So, and we are constantly improving on this too. So to give you the opportunity to have a look into the data. And it's also a good opportunity for us to understand prediction in more cases better to improve the algorithm, especially for elevation or data quality. That's the most thing here. Data quality is key. So if the data is not good or just not there, prediction is impossible. That's a fact. So the race should be over. So I can also forward the start times. And yeah, we can have a look at the player again. And now the people are all in the finish. The race has been finished. And if I use the slider here now, I can do an instant replay. So it's just smoothly working. And then you can share this race, or your customer, the event host, can share it or use it in social media, whatever. Now we are getting to the end of this webinar, and we want to just showcase a little bit the roadmap. I showed you how easy it is to use this prediction feature. What you need is timing hardware that is able to produce a combination of BIP, time, and GPS location. There is a scenario where when you don't have GPS location, we can also help you. This is a bit more complicated, but you can find it in our documentation too. Use our documentation to help yourself or just get in contact with us. What we will do, or we want to do, is maybe integrate more timing systems. So the world is big. There are different systems on the market, and let us know your needs. So we want to enhance the prediction algorithm itself. So I showed you we have this error metric where we can measure if we have improvements, and we want to have greater. For sure, we want to have greater accuracy. We have some ideas how to do it. So stay tuned to get to know what we can do. So and then there's the new feature we are currently working on. It's called Ghost Participant. I will shortly explain what this is. So you've seen our maps, and there's this one use case maybe where you have the best time of this track, of this marathon or whatever, this half marathon from the past, and you want to show in the player everything else related to this fast time. So this is the idea. You will be able to set up a player, give him a time for the race, the record time, and then it will progress over the map too, and all the people can see, okay, this was the track record, and I was so much behind, and so on. Or maybe you have some other scenarios where you can use this feature for. So I think I said everything to give you an impression of our prediction system. And yeah, I want to thank you for tuning in and joining. So I hope you have a feeling that it's easy to use, and encourage you just start testing. So register to RACEMAP, try it out, get in touch with us. We will be happy to hear from you.